Alright guys, so the first run with the 66 Tele, I guess we're going to start checking out some of the electronics. I want to try to get this three-way switch functional, CRL 1452 three-way switch. I don't know if the camera will bring it up, but there are these little tabs and there is a blade that's attached to the switch lever here. Now that blade slides through those tabs, and what happens a lot of times with these switches is from maybe the pickup selector being in a certain spot or just overuse, the tab where the blade passes through just kind of gets worn out, and it's supposed to have a little retention on it. So I've went in and retensioned them all, and it's really just a matter of going easy with a small screwdriver and just kind of pushing pressure so it's actually got tension on that blade when it slides through. So if I'm looking down at this now, I'm looking at it as it would have been wired onto the control panel. So this hookup would be going to the output. So basically the volume pot and then to the jack. So that would be our signal. And what I do is take my multimeter, and if you have this cool audible continuity function, this beep, that means that you have a connection, obviously. So we're going to hook the output to one end, and we're going to hook this to, this would be where, so if I'm looking at the switch, we'll put it in the bridge position so we don't get any surprises. So this would be where the neck pickup would attach, right here. We hook this up and it shouldn't beep. Okay, we're good so far. No beep. Now let's swing it into the neck position. Okay, we're working there. So now it doesn't shut off in the middle because the middle position shares the neck and the bridge. It shuts off in the bridge. I may have fixed this. This is going to be good. Now we'll try that where the bridge pickup hooks up. So we'll put this in the neck. That's where the bridge pickup hooks up. So we go to the middle. We're going to go to the middle first, obviously. Okay, it's beeping there, and it's beeping in the bridge. So it looks like just bending the tabs over on this three-way switch, this awesome old school switch, took care of the problem. You can see what I mean here. So sometimes these tabs here, as you can see the blade passing through these tabs, you just need to bend them a little bit. And that's really all I did for this. I knew that could have been the problem because if you wiggle the switch, it would work. So we are good now. We can put this switch aside. Hopefully going to be able to wire up this control panel in a little bit and have this switch in there. That's going to be great. So now as we break our control panel out, I'm not going to attack the neck pickup. I'm going to save that for a different video because that's going to be a little more intense. But I'm going to try to clean up some of the messy solder on here. And I'm also going to try to wire this up like you would see it stock 1966 Tele. Telecaster wiring changed to what they call modern Telecaster wiring, and I think it was 67. Somebody can correct me if I'm wrong. And I'm actually gonna wire it up for modern Telecaster wiring. So as you can see here in this mess, there is so much extra solder and junk. So I know I'm going to swap the switch out. I also want to address the pots. This rear pot doesn't look so bad, but it does have some extra solder on it. I'd like to remove this mess of solder here, and I'd also like to pull the capacitor out and test that. I'm also going to take some measurements on them too and see what they measure out at. See if we can't maybe, if we have a low reading one, maybe we'll put that in the tone spot and we'll put the higher reading one. I'm not saying, 500K, but usually if you get them around 270K or something like that, you put that in the forward spot. Thing with the stack pole pot too, is old pots for that matter. I do believe there's a lot of tone in there, and everybody will argue and tell you it's crazy, but you know, my only suggestion is to try it. I really favored the Bourne's pots in recent times because they do kind of act like the old stack pole pots did. Not only the taper, but the tone and the feel. I really like those. And also the VIP pots from Sebastian at VIP. They were really, really great. They've been great. I know my input jack wiring is good. So what I'm going to do is just detach it there and there because we don't need to really do anything with that. We can just set that aside. And when I wire this back up, I'm going to try to, like I said, replicate the old look. Not so much the old look because you can't replicate that too well, but I'll do my best to lay everything out the way it was supposed to be laid out. As you can see, this is our volume pot here, and this would be our tone pot with our capacitor here. This is the proper late 60s Circle D cap, and I'm going to try to remove that carefully and test that right now and see if we're in range, we're in spec. Now, somebody made a good comment about ceramic capacitors and being microphonic, and I have seen paper and oil caps, especially my Flying V. I had a microphonic 0.022, but all I can do for now is test this. And they also gave me that comment regarding the microphonics I was having with the neck pickup. I would think that if the tone cap was microphonic, it would also recreate the microphonics in the bridge position, and as we know from referencing the video, it did not. So I'm going on the fact that the Tele neck pickup, I'm thinking the cover is rattling, so we're just going to focus on that, but I want to get this capacitor out and test it, make sure it's in spec. This is just an ESR meter. It's kind of a cheaper one. It's not a real fancy, you know, extra pickles, no onions, but it gets the job done. It's pretty straightforward. Turn it on. So here we're reading 000, and the cap is a 0.05. So we would hook our leads up and see what we get. Okay, now sometimes you have to check the ranges. So 42 nanofarad, you get yourself another capacitor of the same value. So this one is actually reading high. And also, if your voltmeter has a capacitor setting, you can triple check. So there you are. The UF reading, we have about 0.046. Cap is a 0.05, so I would say we're pretty good. Cap tests out good. So we'll put that aside as well. That will be going back in. All right, let's take a look at these pots here. We're going to try to remove this gigantic solder blob on this ground. Basically grounding the end leg of the pot. And I'm just using a solder sucker. We've now detached it. Can probably hit these while I'm here. You know, we've all been there too. Is you try to get a component that you're wiring up in, and solder is just everywhere, and you can't seem to melt the lug, and you're fighting that old, sometimes contaminated solder. So basically, just get it all cleaned up. Clean all those off, just get all the solder residue out of there. So I'm working with a nice clear spot when I choose to reinstall the wiring and components. So because I don't want to transfer so much heat and damage the trace of the pot, or potentially damage the trace of the pot, I'm going to remove the back of the pot while I work on it. I just find that getting it away from the heat while I'm trying to remove all this nasty solder will increase my chances of it working when it's all done. So I just like to do that and set it aside. And you know, it also gives me an opportunity to get in there and clean anything up, clean the trace, wipe the trace down with a Q-tip and some deoxit or something, and just, you know. One of the first YouTube videos I did was how to disassemble and clean one of these, if you want to refer back to that. But it's really just a series of these little fingers that hold it mechanically together. And once you get it apart, you're left with that. And this is what gives you your ohms reading, is this trace here. This is a big trace of resistance. So we'll set that aside so we don't damage it. Now the fun part. Some wiring stuck here, so I'm going to try to heat that up. Okay, we remove that. So now, I also recently got this solder wick. And I've never really used this stuff, but everybody raves about it. Some guys that I follow on YouTube that do electronics repair, they seem to love this stuff. So yeah, I can see. So it basically just sucks up the solder, but you don't actually get it totally clean. That's not so bad. Okay, so there was some solder on the edge there. I was able to remove that big glob in the center. I'm not sure if I should try the wick or just try the solder sucker. If I can contain it to the center, let me see what the solder sucker can do. Oh, that was a good one. I've now removed the solder. I've exposed the date, which is 0866. I can set that aside and come at this one here. This poor guy looks like it's been through a war. I'm going to let you guys in on a little something. I may have been a bit dishonest. That first pot that I cleaned up was a 66 pot that I had, that I swapped in, because the original one was really scratchy. Knowing full well that I was going to come back through and come hell or high water, I was going to fix the original one with you guys on camera. So forgive me, but I wanted to play the telly. Okay, so I'm going to show you what my plans are as far as the pots. I'm going to get them all cleaned up. I'm going to expose this date on this one. See how much we can get off. It's a little weird. It's clean, but not as clean as the other one that I swapped in. The 18th week of 66, and the original one I took out was the 33rd week of 66. So now we ask, what do we do? I think that it's only right that I put the original pot in there. So you know what I can do too is, if I get the solder cleared off of these, I can take these to work and hit them on the polishing wheel and see if I can get them cleaned up. I gotta think of the right thing to do here. The original pots are dated 33rd week of 66. So this is the original volume tone pot, and it measures out at 275. So I'm gonna clean that up and get that back in. That belongs there. And I'm gonna get the original tone pot cleaned up and put back in, because it belongs there. I was veering off the path of what I really wanted to do, but it just took me a second to really focus. I have everything here that I can fix. I don't know why I even swapped the pot out in the first place. Just take that solder right off. No more messing around. Forgot I had a Dremel. We're totally clean of all solder. We have our dates exposed. 33rd week of 1963. 33rd week of 1966. I'll put that one aside. Okay, let's see what I can do with this one. $66.18, and it's clean. All right, so now that we have a big giant mess here, let's just come in and test this terminal. Make sure we're still alive. 276, beautiful. We'll test this one here that we've repaired earlier. 254. Okay, so we have our tone. We have our volume. You may be asking me, why do you want a higher value in there? I don't know. It sounds weird, but I think it just does something cool. Adds a little treble. Adds a little high end, I think. You know, for a Tele can be really cool. It's just there's a million people out there that'll tell me I'm wrong, and I probably am. I hear something, so some of the greatest guitars I played, you measure the pots and you get in there and you're like, oh wow, how come that's reading so high? Wah-wah pots are the same way. The iCar pots and the wah-wahs, when they start wearing and reading crazy numbers, they're usually the best sounding ones. Again, just my opinion. You have to be very careful with these too, because they can break. But that is all back together. If you really wanted to get technical, hook up the ohms meter. As you can see, we're traveling. I'm moving the pot ever so slowly, but we seem to be working. So if you max it out, you should have 254, and if you travel down slowly. All right. So we have our pots back to life. That only took forever. So first things first, we'll put our switch in. So like I had said, there were some clues that the components in here have seen a lot of heat with the soldering iron at some point. Let's get that on there now. I never liked the big top hat switches. I always liked these small ones. This guitar more than likely had the dark circuit, and when that's removed, the capacitor is a little short, the leg of it. So it looks like they tried to bend a tab and basically bridge some solder to get it to connect. And it did the job. It just, if we're going this far and trying to refurbish this thing and bring it back to life with a refin and doing a little restoration on it, why not make it look somewhat pretty again? So that's what we're looking at. I know I have this to go where it needs to, so maybe I'll do something like this and get that there and get that one there. I'm trying to avoid the pot date here. So basically what I did was stole a little leg off this capacitor just to make a nice connection. Clean joint there. We'll try to get one on the back of this pot here. To this wire. I'm over here trying to save a small 2-inch piece of wire for prosperity, but it looks so ragged that I'm just gonna replace it. These two wires are fighting me the whole way. So what I'm gonna do is ensure that they get hooked up properly, because I'm not messing with it anymore. It seems to be Just busting my balls no matter what I do. I'm gonna get this tucked away like that. Make a mechanical connection. And then I'm gonna come back through with this other wire going to the switch. Make a mechanical connection on that. And now I'm gonna solder it. Alright, so a bit cleaner. Solder joints are clean. And I'm thinking we can still test the pickup function, or we can still test the switch and all the components. I've put both pots turned full up, and we'll take an output, we'll put it on the output of here of the jack, and then we'll take this. We're in the neck pickup now, so we'll just put it here. Check the case. We're ground there. Cap is ground. Jack is ground. That's grounded. We're connected. Alright, I think we're good. We're good. I think I'm just stressing myself out for nothing. We're obviously connected. So, we got the switch working, the original switch. We have the proper layout of the wiring, how the telly should be. I just curled it there for some looks, make it look a little better, a little cleaner. We tested the capacitor. The capacitor works. We cleaned all of the extra solder off the pots. It was a mess. We also were able to expose bulk dates on the pots. So the control panel, for a few minutes time, is good to be put back together. It's good to be installed. We should have no issues. I'm going to do the neck pickup repair in a different video, like I mentioned, because that's going to be a little more in depth. There's a few different methods. Well, there's one method I'm hoping to try without having to wax pot the entire pickup, so we'll get that. And then, yeah, if you guys are into this 66 Tele restoration, just stay tuned, because, you know, it's a little stressful because I've got stuff falling around everywhere, but it's going well so far. We have all the original components back in here. Some wiring we had to replace, but that's kind of, you know, it's a given. I'm not going to split hairs over a, you know, a tiny piece of wiring. So I'm good with that. I'm happy with this layout, happy with the way it looks. We have the proper three-way switch, two good working pots. We have a 275K here, 255K in the tone. The 0.05 capacitor has been tested. It is working and it is hooked up properly. Input jack wiring and cup, all that is there. We're properly wired up. So we get the body back. We start hooking up some pickups. But the next video will probably be me fixing the neck pickup. So hope you guys dug it. Don't be afraid to solder. Just read up, research it. We got the electronics back to stock. 66 Tele.